Hello everyone, this is Vasuki from IT department of Griet here to demonstrate our project on strategic customer retention on harnessing machine learning for proactive churn management. Coming to our abstract, our project aims to analyze and detect the customers who are likely to churn from the company. Churn refers to the measure of how many customers stop using a product. This churn rate possesses a risk and challenges to companies due to its impact on revenue of the company. This study provides assistance in the banking sector by using ML techniques to detect customer churn. By doing so, the company takes preemptive decisions and changes among the product or services. The specifications for our project include the hardware requirements are a processor of i5 or i7 generation or more, memory of 8 GB or more, storage of 256 GB or more. The input devices are a keyboard and mouse. The software requirements include an operating system of Windows 7 or more, an Anaconda Navigator or Visual Studio, and Python for programming version of 3.12.4. The Python libraries used for the execution of our project include Pandas, NumPy, Matplotlib, scikit-learn, joblib, tkinter, and the interface used is GUI. The diagram shows various attributes related to our user customers, including credit score, customer ID, balance, tenure, gender, age, years as a customer, and whether they have a credit card or not, if they're an active membership in the country, and their estimated salary. The class diagram shows classes for managing customer retention. The database stores customers, customer tracks information, retention strategy defines strategies, offer providing special deals and reports list at risk customers. Methods include updating data, analyzing behavior, and generating reports to prevent customer churn. The activity diagram shows the steps in a data science workflow, loads data, pre-processes data, performs exploratory data analysis, does feature engineering, builds models, evaluates models, selects the best model, tunes the hyperparameters, and finally saves and deploys the model. In the sequence diagram, the user starts the process with the system, loads the data, prepares the data, analyzes and creates features, and builds a model using them. It evaluates it and then chooses the best model and tunes it. This model is saved and deployed, and the final end user uses this model. The deployment diagram, the users interact with the interface to the bank server where internally the model prediction cases take place, where the data is sent to the server. As for the system architecture, it involves several stages. It begins with data collection from a bank, followed by exploratory data analysis to understand the data. The data is then pre-processed, which includes cleaning, handling missing values, creating dummy variables for categorical attributes, and standardizing the variables. The dataset is split into training and testing sets, and data balancing techniques like smooth are applied. Various machine learning models are trained and optimized using cross validation. The models are evaluated based on accuracy and other metrics, and the best performing model is deployed for making predictions. Finally, the outputs and predictions are analyzed to understand the factors contributing to customer churn, providing insights and recommendations to improve marketing campaign and retention strategies. The working process for prediction customer churn in the banking sector involves several key steps. It starts with the initial data analysis where the dataset is loaded and examined. This includes pre-processing procedures such as cleaning the data, treating missing values, and encoding categorical data. The dataset is then split into training and testing sets. Various machine learning models, including logistic regression and decision trees. The algorithms used in this project are KNN, random forest, SVM, gradient boosting, logistic regression, and decision tree. Coming to our source code, the implementation primarily involves the use of Python programming language and its associated libraries. The essential steps of the source code include importing libraries such as Pandas, NumPy, Seaborn, Matplotlib, sklearn, and imblearn. They are imported to handle data manipulation, visualization, and machine learning tasks. GUI components are managed by using tkinter. Coming to logistic regression, a linear model used for binary classification that estimates the probability that an instance belongs to a particular class. SVM, it is a powerful classification algorithm that works by finding the hyperplane that best divides a dataset into classes. KNN, a powerful classification KNN, a non-parametric method used for classification by finding the majority class among the k nearest points. Decision tree, a model that uses a tree-like structure to make decisions based on feature values. Random forest, an ensemble method that constructs multiple decision trees and merges them to get a more accurate and stable prediction. Gradient boosting classifier, an ensemble technique that builds models sequentially, each new model correcting errors made by the previous ones. The working process includes data collection. Customer data from a bank is collected and analyzed. Exploratory data analysis. Data is examined to understand patterns and relationships. Data preprocessing. Data is cleaned, mined, and missing values are created. Model training and evaluation. Models are trained on the training dataset and evaluated on the test dataset. Model deployment. The best performing model is deployed to the predict customer churn. Insights and recommendation. Based on the model prediction, recommendations are made to reduce customer churn. In this way, our project aims to determine the customer churn rate of a bank, allowing for the company to make necessary changes or implementations, improving the overall revenue of the company.